Now suppose that we want to get our margin of error down a little bit, that we want to repeat this study but with a smaller margin of error, and we want to know what sample size we need in order to do that. Just like what we did with a proportion, we can take the formula for margin of error and solve it for n here, and that gets us this, in which this sigma tilde, this would have been s if we had just solved the formula. This sigma tilde is any estimate of the population standard deviation. The only reason we didn't just use S here is because if we're thinking about doing a study and we need to know what size sample to use, we might not have a sample yet, right? We generally don't. At least we don't have the one that we're going to use for this particular study. And so we might not have a sample standard deviation yet. So we have to use some estimate for that standard deviation to know what size sample to get. In this description here, we're talking about doing a follow-up study to estimate the same quantity that we just estimated. And because of that, we're going to go ahead and use the standard deviation from our sample as an estimate of sigma tilde. So we have been told that it's okay to use our S, the value S from the previous example, or from previous study. And that standard deviation was 9.656. Note that we are not using the standard error. We're not using S over square root of n. It's really just an estimate of the population standard deviation, not of the standard error of our statistic. Anything that incorporates a value of n couldn't really apply here in this context where we're really trying to calculate what value of n we need. So we'll use that S for our sigma tilde. And this margin of error in the denominator, this ME, is the margin of error. That's generally something we pull straight from the description. We don't want to use the margin of error that we calculated in our study. The whole point of this is that we are trying to get a smaller margin of error. We're going to redo this with a smaller margin of error. So really the margin of error is either explicitly stated as a margin of error, or it's described as within plus or minus some number. So that tells us that our margin of error here is 2. The fact that we want 95% confidence tells us that our Z star is going to be that critical value of 1.96. Note that we're going back to Z here instead of using T. The reason we don't use the T distribution for this formula is that the T distribution also depends on n. We have to know what n is before we can know how many degrees of freedom to use in that table. So this is always going to be a little tiny bit maybe of an underestimate, but what tends to happen in these cases is that by the time you care how small your margin of error is, you have a value of n that's so large anyway that in many cases it's going to be all the way off the end of the degrees of freedom listed in your table. So if we're close to n equals 100, it really doesn't matter whether we're using T or Z, and sometimes these come out to be 10,000 or something. Sometimes they come out to be very large values. And that's why it's okay to just go ahead and use Z star in this formula in general instead of T star. So we'll go ahead and plug in now. We've got n equals our Z star of 1.96 times our sigma tilde, which is 9.656. The whole thing divided by the margin of error, which we decided was 2 grams. And then we do have to square this at the end also. So bringing in our calculator, we've got 1.96 times 9.656 divided by 2. Calculate that whole inside and then square it to get 89.546. Let's go with 89.5 for here. Of course, we can't weigh 0.5 kittens, so we will round up. Just like we did with proportions, we always round up. We don't round to the closest value. So we would need 90 kittens for this study. The most common mistakes that I tend to see in these sorts of calculations have to do with correctly identifying the margin of error. Just look for a description in the statement. If you see a plus or minus on any number, that is probably your margin of error. Otherwise, you're going to see the words margin of error explicitly stated. If it's a follow-up study, we never go back to the margin of error we already calculated. All that's going to give us in the end is the value of n that we already used. It's not going to give us the value we need for this smaller margin of error and more precise estimate. So very simple formula, but again, it's mostly about knowing what this sigma tilde is, knowing where to find our margin of error, and understanding that we would use a z-star rather than a t-star in this context for the reasons we already discussed.